But anyways, once again, my name is Garett, and joining me today is my partner Dave. And thank you all so much for coming today at AI Camp Seattle to give me the chance to be able to talk to all of you and share with you about my talk, LLM evaluation and observability. The goal for today's talk is to be able to give everyone a framework to think about LLMs and agents and the failure modes and be able to have better conversations throughout. So before we go on, let me just do a small introduction about my company, Truera. So we are we are a startup in the AI ML space. Our founders, Anupam Dada, Cheyenne, were from Carnegie Mellon. Anupam Dada was a professor at Carnegie Mellon. They both spent about 8+9 years looking into AI explainability and governance, and developed the first methods for explaining ML systems via shifty values, being able to look at feature influences and how a feature will affect the final prediction of your ML system. We've enterprise AI expertise from a lot of different companies, and our business really is in the full lifecycle AI observability. This diagram over here shows the 3 layers of AI systems that we sort of think we can classify them today. So within this diagram, on the left-hand side, you have the development phase. On the right-hand side, you have the production. And you have sort of 3 layers going on. You have the storage, where you might have your model repository, where you might have your vector databases. You have the compute, and this might be either OpenAI's GPT 3.5, or you have Cloud Anthropic, or you might even run your own models. And on top, in the observability layer, is where we are most interested in. We're interested in testing and debugging your applications in order to help you ensure to be able to say to yourself and for your businesses that you are providing good answers, responding to users with good answers, and be able to really know where you stand today. We also have a open source application called TrueLens, which I'll be talking about more later. That's sort of in the testing and debugging layer. So let me just do a quick show of hands. How many of you here today are experimenting with Gen AI, LLMs? Anyone? Let's see a couple of hands. Nice, that's a lot of you. And maybe a follow-up questions. How many of you here have Gen AI systems in production? You're using LLMs and you have a chatbot. 1, 2, 3, 4, 5. Thank you so much. So this roughly correlates with what our findings have been so far, our user research. There's a lot of interest and hype around Gen AI and LLMs in applications, but it's also really hard to sort of bring them into production. And I don't know whether you guys have gotten a chance to see this today, but there was an executive order on safe, secure, and trustworthy AI intelligence that was presented by the White House today. And one of the points they highlighted was to develop standards, tools, and tests to ensure that AI systems are safe, secure, and trustworthy. And this is always tough because, so this picture over here is taken from when Cloud 2 first came out. We were like, oh yes, who are the founders of Truera? Hoping to get the correct answer. We got this really long, authoritative sounding answer. And I won't bore you with the details so much, but the only thing that we really got correct is that Anupam Dada is one of our co-founders. It got the year wrong, it got the 2 other co-founders wrong, it says we are quiet, and which we actually are not. And so in today's world, we would like to encourage people to consider LLMs hallucinatory unless proven otherwise. And this, we think, is actually a feature and not a bug. Why? Because decades upon decades of ML research has optimized models for generalization. We have our training model, we have a training data set, and we want to say that, given this training data set, we want you to learn as much as you can from it. We want you to be able to extrapolate and figure out how to predict when given data that hasn't seen before. We want the ML models to generalize. And while we are training it to generalize, we penalize memorization. We don't want it to overfit to certain examples. We don't want it to overfit to our training data set. We want our models to be generalized to perform well in data that is before. And this overlap is really murky, right? How do you know when you're going to generalization? How do you know what is memorization? Where is the overlap so far? And this decades and decades of machine learning influence it's sort of causing this issue of hallucinations that we might have seen so far. So as an industry, we've sort of moved to this idea, if this overlap is murky, if this isn't necessarily the best way to do things, let us focus LLMs, let us focus these models on what is better at. It's good at generalization, it's good at things that like summarization, where you can sort of generalize it to a certain pattern. It's good at things like for getting embeddings, it's good at query inference, it's good at query planning. And leave all the other things, the memorization part of it, to something else. And this is sort of what we have kind of converged. And to leave the memorization to something else, we have a knowledge source. This can be in two large categories. One of them, you might have heard of vector databases like Pinecone, like Muverse. And what they really do is to allow you to store your documents, your chunks of documents into a vector database where it can be retrieved based on the similarity. So I think, for example, one very common example is Morgan Stanley. I think they have their financial documents all within the vector database. They can retrieve and query it and allow their financial analysts to answer questions like what do they think about this company, what recommendation would they do, and so on and so forth. The other possible knowledge source is knowledge APIs. So for this, you can think of it as augmenting your your agents with, for example, capabilities of full-frame alpha. If you want to answer a math question and know certain that if you are getting the good response, there also Yelp, Bing, X, Twitter, and so on and so forth. So this general idea we call it retrieval augmented generation, because we have an LLM, we augment it with some sort of retrieval mechanism and allow it to retrieve the information that we think would help it. And this is sort of a high-level architecture of what agents will look like. So just a quick summary for those just a quick summary. So on the top left, you see this question. This is what your user inputs, this is what the user gives to your system. And then you have a translated query. For example, if I were to ask, do you know what a good udon place in capital Q Seattle is? And then it's able to say, okay, based on this user's query, I think that I should be making a Yelp call, for example, with udon and the location capital Q Seattle. And it passes on to the API to Yelp, for example, gives it to the reasoning loop where your agent can determine, hey, do we have enough information? Do we think we have the information we need? Do we need to make more API calls? Or we think that we have enough, and then we are able then to summarize, complete, do the general tasks, and then give out a good response. And this system has sort of has been working so far because, for example, we created a little app. We just wanted to ask, what is the address of Gumbo Sushi in San Francisco? This is a restaurant. You can see the address is right here. If you were asking ChatGPT 3.5 directly, you get this answer. It's really long, but the short thing is, well, it's 53 Clement Street, San Francisco, which is not a valid address. Whereas if you pair it with Yelp's API, for example, and you can give it, and you can see that it actually is able to pass back the correct answer. So this retrieval augmented generation architecture is really able to help find irrelevant contextual chunks for it to be able to let your app, let your agent summarize and give correct answers for your users. But there are, of course, failure modes. Whenever we add something to the system, we introduce bugs, we introduce failure modes, we introduce more ways for the things to fail. So here are a quick list of where things could fail. For example, one, we might select the wrong two selection on input. Instead of using Yelp, maybe it uses some other, like Google or Reddit, for example, and the answers might not be as accurate. You might also see where there's failed API calls, maybe things didn't go well, maybe you get a 200 OK and you get something else instead and you don't get the correct information. Maybe there is an infinite loop because your agent, when deciding whether it's enough information or not, just decides to go on the loop over and over again and gives you no results. Or maybe, even if after all of this, it still hallucinates a wrong answer and thwarting all your efforts. And we think to structure the conversations around this, we think that this is a very useful framework to think about. We call this the RAG triad, the retrieval augmented generation triad. And this is a very busy diagram, so I'm just going to dissect it a little slowly. First off, you have this triangle. This triangle is composed of the query, which is what the user provides. We have the context, which is what your LLM app retrieves. And we have the final response, which is what is the output of your app. And along with this, we see that there are 4 main failure modes that could happen. 4 main things that we're interested in. For one, query translation. When we ask it, hey, what are the best udon places in Capitol Hill, Washington, Seattle? We want it to be able to craft the correct query, right? In terms of context relevance, if I ask it, oh, what is Dave's favorite food? But it gives a list of Garett's favorite food instead. That wouldn't be really relevant. In terms of groundedness, we want to make sure that the response that we are getting is linked to the pieces of content that is fetched back. And in terms of answer relevance, we want to make sure that at the end of the day, after all of that, your answer actually answers the question, which is the whole point, right? So you don't really want to hear me talk too much, and we would rather prefer interactive mode of interacting with this. So we've actually prepared a little chatbot of sorts, and this is a restaurant information chatbot. This is some of the high-level architecture of what I'll be showing and demoing to you later. And you can see it really is a more simplified version of the AI agents that we are sending to you later that we showed before. We have the question, we have the translated query, we'll be using Yelp to sort of answer the questions. And based on the query and relevant chunks, we'll summarize them and give you back the results. And I will also be doing a quick demo with TrueLens and sort of show you how it can be used in conjunction with your LLM apps, with your LLM agents to be able to give you more valuable insights into what you have. For those of you who are interested, we have prepared an education notebook for you. This is also available at tinyurl.com/agent-eval. And yeah, I mean, this will also be here even after this talk. So feel free to maybe record the link and let me get to it. Okay, so if for those of you accessing the notebook right now, you'll see this notebook. At the start, we give you some context. This is an app, agent-based, that is built with Llama Index, and we use Yelp as a knowledge API to sort of retrieve retrieve pieces of information that's relevant to answering the question. We'll be using what we call feedback functions, but these are really just evaluations to evaluate your app based on the triad and the elements that we discussed before. And yeah, so you can sort of see how we get started. A lot of it is pretty similar. You would import the normal things that you would your normal OpenAI agents. You would have your Yelp API key and your client ID, for example. For agents, in particular, Llama Hub has this thing called the Yelp Tools spec that really just enables tools. In this case, it's business searches. In this case, it's also reviews. We gave it a Gordon Ramsay prompt, so we asked you answer questions about restaurants in the style of Gordon Ramsay, which is why people might have seen the responses for Gamu Social just now were a little more flowery than expected. Yeah, and so not too much is interesting here. This is kind of how you would create an app with ChatGPT 3.5. The one curious thing here is add instruments, which is one of the 2 things you really need to just get started with TrueLens. And here we can have, here we start the TrueLens application itself. And here is where we can, so as I said before, Truera is in the business of observability. That means evaluation, that means understanding how your application is doing in the development time during production as well. So to complement that, we in TrueLens have what we call custom feedback functions, which basically are a way to come up with a score for your own needs. For example, you might want to see whether the final answer has any personal identifiable information, any PIIs that would make you violate privacy laws. Or in this case, we're looking at query translation score. We're looking at whether the final output uses ratings at all. moving down, we also have feedback functions that are out of the box. And really, all that is to see here is that we have a lot of feedback functions that come out of the box that really just needs 2 lines to set up without the spaces. And we can also allow for ground truth evaluations. These are where you have the ground truth of what you expect the answer to be, and you can compare the answer that's obtained by your app against this to be able to understand, hey, how well is my app performing right now? So if you take a look at what we get out of the dashboard, you can see we have an OpenAI chat completion here, and we have a Yelp agent here. And you can see that simply by having this agent structure, we are able to improve the answer relevance and ground truth eval scores from 0.22 and 0.02 to 0.78 and 0.72. And if we wanted to, we could take a look into it, figure out what the user inputs are, click into them. You can also see what the outputs of the feedback functions are. And we can take a look over here. This question asks, does Juniper in San Francisco serve pastries? And you can see that in this case, our LLM says, oh, yes, Juniper does serve pastries, blah, blah, blah. And we can see, okay, why do we think that this, you can see that we evaluated this to get a score of 0.25, which means that it's not really grounded in the context. And we can say, okay, this is why. Yes, Juniper does serve pastries, and this is a strong evidence. In terms of the other statements, let me tell you that pastries are nothing to write home about. There is no evidence found. They're mediocre at best, there's no evidence found. And from this, you can sort of, you're able to sort of understand why LLM evals are giving these evaluations. And if we head on back now to this slideshow, yeah, we can sort of see that we have all this enabled, and this is some of the failure modes. And query translation, for example, verifies that we are actually retrieving the correct queries, we are making the correct API calls. Context relevance, for example, which asks whether the query and the context are related to each other. If you want the address, then we get the address. Groundedness, for example, asks, hey, does my final answer, the address of Gambo solution is this, is it supported by what is given in context? This is a very interesting measure because low groundedness scores doesn't mean necessarily that your answers are inaccurate. For example, over here, for example, you see that this in the final answer, it says, oh, I recommend trying them out, but be sure to have low expectations. There is no supporting evidence, but depending on your use case, whether you might be just creating an app just for like a social chatbot, for example, you might not worry too much about that. Or, for example, if you were in the financial services, for example, you might be more interested in, am I able to say where all the statements that my app is making are coming from? This is an example, this is a second example of that. Over here, you see that Lombardi's pizza has been serving classic New York style pizza since 1905. If you were to search Google Lombardi Pizza New York, you'll be able to see that it actually does, this chain, this business did actually start in 1905. But the reason why we are putting groundedness here, like a score of 1, is because nothing in the retrieved context tells you that it actually does get a score of 1, which means that all of this actually comes from somewhere within the model itself that it's hard for you to trace back and point to what, where this piece of information comes from. Again, depending on use case, this might be good, this might be acceptable, this might not be acceptable. Lastly, whether the question answer relevance is helpful. Here, what's the address? We get the address, very helpful. Here, what is the best diner? Just have low expectations, so on and so forth. Not too helpful. Again, coming back to this, we think that this right tree here is useful to help structure conversations. If instead of saying my LLM app is failing, instead of saying my LLM app is not performing too well, it's getting low scores from users, we can say, hey, I look at my LLM app. My LLM app is not retrieving a proper business context. What does that mean? That means that when we link to our knowledge APIs, when we link to our vector databases, maybe we need to get more pieces of information. Maybe we need to do something about how the query embeddings are being generated. If we are saying that, hey, my response in my context, my response is not grounded in my context, what does that mean? It means that you're not using it to summarize it properly. your LM is just filling in the gaps which you might not want it to. And all of that is a lot to take in, but I'd like to sort of leave everyone with some closing thoughts of sorts. Maybe you can do the question and answer at the end of it. Thank you so much. So we think it's hard to productionize LLM apps. If you can see just now from the straw poll of how many people are experimenting versus have deployed LLM apps in production, it's really hard because there are right now two camps, right? There's one camp that's building really cool prototypes. If you want a demo that just works 80% of the time, then you can control the inputs, they can control what the output looks like, and make it very impressive for people judging you. That's easy. If you want it to go into production, you have to worry about how am I getting this data, how am I securing this data, how am I making sure that what the kinds of answers that my LLM agents is giving back makes sense. These are 3 examples from users that we've talked to, from people that we've asked in the industry who are looking at this question. For example, in education tech, imagine if your LLM chatbot meant to help students, for example, were to give the correct answer 80% of the times, but 20% of the times that goes off in a viral tangent. How confused would you as a learner be? We have another customer who's sort of using LLMs to try to summarize core transcripts to get action items. If you miss out action items from your customers, or if you miss what a customer wants, that will leave a very bad reputation in your company. Financial services. If you were to create a chatbot for your customers, and they were to make financial decisions based on your answers, wouldn't the consequences be really severe? And the main difference between the two camps is really just about systematically iterating to improve them both in developments and in production. And to do this, you want to make sure that whenever you're building an LLM app, when you're making agents and stuff, you want to make sure that you're really evaluating your LLM app and agent. You want to make sure that, if you have ground truth, you can have human evals to look at the answers to see whether they make sense. You can have LLMs and evals to make sure that to automate the evals in a certain way as well. You want to see what the cost is like in the case of agents, or in the case where your RAG structure, your RAG architecture involves a lot of different costs. You want to find out where the missing piece is. You also want to track, because there are a lot of hyperparameters when it comes to LLMs. You want to choose maybe the correct models, you want to retrieve a certain number of pieces of information, and so on and so forth. We are building TrueLens because we believe that it fills a gap within this industry at the moment. We think that it is able to sort of satisfy the criteria that we have right now in terms of broad support, in terms of being able to have effective, comprehensive evals and experiment tracking as well. And in terms of your evaluation support, be it TrueLens, be it any other tool you end up using, you would want to think about all of this. Are you able to detect PIIs, for example? Are you able to detect language mismatch? If a customer were to ask you something in Spanish, will you answer in Spanish, or will you stick to English, for example? And you might lose the customer that way as well. In this, given how quickly the ecosystem is changing as well, we want to make sure that whatever you're experimenting with might not be what you end up using. For example, if you use ranking one moment, number index one moment, you want to make sure that whatever eval mechanism you have does support all of this. And finally, as we say, tracking the experiments to select the best configuration. So once again, this is TrueLens. We invite everyone to give us a star, request a feature, and contribute. And it really just boils down to this. We think that the future of how this AI 2.0, how this Gen AI develops, is not really one that can be controlled by any single one team, one company. We think that is something that has to be done with you guys, with all of you here, the community. We want your input. We want to hear how we should steer ourselves towards ensuring a more trustworthy and effective AI 2.0. And finally, we'd like to invite you to connect with us. This is our X/Twitter. We also have a Slack. We call it the AI Quality Forum Slack. In it, we have bi-weekly paper readings. So the last paper reading we did, for example, was evaluating LLM as analogous reasoners. And we sort of look at all this state-of-the-art research to sort of talk about how you can use them too in your production. And again, this doesn't really, you can use it even though you're not using TrueLens or TrueError. We just really want to hear what the community has to say. And with that, thank you so much. You've been such a great audience. And thank you.
Any questions? Yeah, all right. I've got a second mic here. Go around.
Yeah, thank you. I have two quick questions. One is you mentioned in one of your slides you said so you asked which is the best standard in Toronto, and the answer basically has some like a wiggle room, says okay based on your personal judgment, preferences or something, and you gave it 0.7 score versus a very assertive answer in the previous slides. Generally I feel like if you can give some flexibility in your answer, generally that's a better answer than, very assertive, because people do have preferences, right? So I just wonder how can you factor that into your evaluation? That's the first one. Second is I checked out your structure of your rack, and I didn't really find anywhere you cache your prompt and like previous answer or something. So I just wonder how, if you do that at all, because, from my point of view, the standard RAGs structure always have some vector database, which you cache all your knowledge and for this prompt or something. And then, you can generate new things and, have this prompt chaining, somehow. So can you explain a little bit if you do that or not?
Sure. Is it okay if I summarize what I'm hearing from you as the two questions so that the audience?
Sure.
Yeah, sure. So maybe let's start with the second question first. Your second question was whether we cache the prompts because typical RAGs are connected to vector databases. They sort of retrieve the information from the vector databases. And is that right?
I think so.
Yeah. So TrueLens, how it works currently, we have by default, it connects to a SQLite database that sort of stores your prompts and everything as well. It also has connections to SQL to sort of log all your records and everything. If you're asking about whether we use a vector database by default, we can connect to Rivers, we can connect to Python, we can connect to other vector database providers. For this particular notebook, for example, we didn't choose to do that because the knowledge APIs, in this case, the Ops API, sort of serves as the knowledge from which we can get information from. Does that answer your question?
But I think if you cache your previous answer and the prompt, that will give you like enriched knowledge in your following question answering. That's my understanding, right? Because you basically lost your previous information in your previous questions, right?
Are you asking about in terms of like when you're chatting, you have like a little session history, for instance?
Right. And also, it's basically give you a faster, response if you cache all the information in your database, right? Yeah.
Sure. So we are not constraining the users on how they use it because everyone has different use cases. Maybe some of them are using apps that they are chatbots. Maybe some of them are using more particular interesting user interfaces. And that can be, in terms of how we feed it back to us, we can support sessions as well. And maybe I can talk with you offline about this as well. Sure. Thank you so much. Yes, please.
About the first question.
Oh, sorry. What's the first question?
How do you factor in the flexibility of your answer?
Right. So the short answer to that would be that the flexibility of answers, we can ask the LLMs to give, we can give the LLMs a prompt, and in that prompt, we can sort of classify it. Firstly, it's not a binary 0 or 1 whenever we give a feedback function. There are cases, for example, back in our TrueLens examples, we have 0.3, we have 0.5, for example. And then second thing is when you're looking at scores, you're never looking at 1 or 0, right? You're always looking at like, hey, maybe 0.7 is for my use case, for my particular scenario, what I deem it to be fit. We're not saying that, oh, anything below 1 is unacceptable. So in that case, this is like presented just now, 0.7 might still be acceptable for your use case. If you think that's not acceptable, you can ask it to be more strict. You can say, hey, a 0.8 score means that it answers the question directly. At least 80% of the statements must answer the question. First to start, 0.7 means something else. Okay. I'm happy to talk to you offline. Yes, please.
Thank you very much for the talk.
Thank you.
So my question is like, we create like personalized messaging.
Yes.
So if we have to do evaluation at scale, let's say that 1 million messages, how would that work? Like from a compute perspective or pricing perspective, and even from a time perspective.
Sure. Thank you for answering that. I do have I think it's quite just for this. So there are a lot of questions that people ask. I think for your particular point, it's a lot of think of it as a pyramid of sorts, right? You don't necessarily, for production use cases, you don't necessarily need to run every single eval with every single message all the time. There are a couple of strategies. For example, we have this diagram over here. On the y-axis is scalability, on the x-axis is meaningfulness. When you're looking at development, for example, you might be looking at human evals, you might be looking at ground truth evals where you have a certain knowledge, where you can test rigorously certain use cases for the messaging app, for example. But when you do in production, for example, what you might want is to rely on Blue or Rook for traditional NLP evals. You might want to look at MLM, which uses smaller or even free models. Some of them are available in Hugging Face, for example. And you might even do sampling, for example. You don't need to test all of it, just some of it as well. And these are some of the considerations that you might have. Yeah, you can sort of choose the right combination. And you can think of it as, I wouldn't put a pyramid, but when my security professor was teaching me, he said security is like Swiss cheese, right? Every layer has sub-goals, but if you stack a couple of them enough, you might be able to achieve what you want to achieve. In the case of production monitoring, for example, you might use traditional NLP evals, NLM evals, LM evals, experimentally human and ground truth evals, and use them to flag possible cases that you want a human to look at again properly, or you want to use that to add to your subsequent test cases moving forward. I hope that answers your question.
Thank you. Just a slight follow-up. So many times, for example, these messages which we create have to be aligned with a client's branding.
Client's branding?
Like a client's branding. Like, there's a particular, let's say, if you're creating messaging for Coca-Cola.
Yes.
So they want certain kind of messaging.
Yeah.
And when I create messages like 1 million of those kind of messages, it might become really difficult to sort of it's an extinction event for a small company.
Yes.
You send out a bad message and a contract is over. So how can we be like really strict about not making a mistake? Is it even possible? That would be a question.
Sure. Here, let me give you some thoughts and feel free to connect with me and follow up with me as well. So I believe that when you're sort of generating these messages, you're not going to generate all 1 million at a time, right? You might want to start off with a smaller set of 100, test how well your prompting and everything works before you go and so forth. Right? You sort of figure out how your system works before you say, hey, should we trust it to go on further? Should we not trust it to go on further? And so forth. And so that is one possible way I can see it happening. So to some small sets, augment with what you've tried and tested and works, doesn't work, works quite well, but it's a little bit tweaking and so on, and improve your one further. But yeah, I'm happy to connect with you offline, and same goes for everyone as well. Find me on Slack or Twitter. Do we have time for a question? Or?
No, I think we are done with that.
Okay,
yeah.
sorry. So
we can
thank you all so much. I hope you all had a good time with me. Connect with us, and thank you all.
That was awesome talking. Yeah. I actually remember a few AI camps ago, I asked a question that was like, is there any way to like measure this, post yeah. Is there like a way to test or like put a number to the trustworthiness of it? And nobody had an answer. And I'm so glad that there's like finally like a concrete way to kind of get like feedback. Do you guys like give like suggestions to your customers for how to make it more like?
Yeah, for that particular use case, maybe we can talk.
Oh yeah.
Yeah, we're going to talk offline with you, especially for anyone else who has a use case that might be more specific. We are happy to talk with you and connect you with one of our solutions architects.
Awesome. Okay, it is now time for our second speaker. Beibin, sorry, did I say?
Beibin Li.
Beibin. Okay, here you go.
Hello, everyone. Just Zoom check.
Hello, everyone. I hope the slides work. I designed my slides by using PowerPoint, but there are some security issues. I cannot show it, connect to the screen. I guess my laptop just doesn't like this room. Well, so we convert the slides into Google Slides next Studio, and I hope the animation will go smoothly. So by the way, I'm Beibin Li, so from Microsoft Research. My background is a little bit on the research side, but today I'm going to introduce the AutoGen multi-agent conversation framework for AI models, including LLMs and large multimodality models. And our tool, AutoGen, is free and open source on GitHub. And here are a few links here. And we released AutoGen in late September, so it's roughly slightly over a month. And during the past month, we get 1,400 stars in GitHub. And from the open source community, we see a lot of different applications, including use AutoGen to design self-improving agents, video games, data analysis, or some web scraping and literature review to write papers or connect for you. So what are agents in large language model? As we know, in the traditional computer science and reinforcement learning, we see there is an agent and an environment. So the agent will first observe the environment and then do some reasoning to take actions, and the action will also influence the environment. The definition in LLM is similar, but with additional few considerations. The first of all is reasoning, let's say train of thought. How are you going to take the train of thought in the environment, interact with the context? And another thing is action, including tool using. You can use Python, you can use Google or Bing to search the internet. You can use Wolfram Alpha to do some complex mathematical reasoning and calculation. And there are more, for instance, adapting to the new observations to learn new skills. So we have a lot of agents you see nowadays, including AI chatbots. The ChatGPT is the biggest one. And for sense discovery, and for education purpose. There are many different types of agents, and now on the hype is the GPT-4V, where you can use agents to draw diagrams or understand diagrams and images. So there are so many types of agents. And as Aristotle said, the whole is greater than the sum of all the parts. How can we take everything together, make an integrate whole part, rather than just simply sum them together? So we come up with a multiple agent coordination with AutoGen. It incorporates different language models, including the expensive one, GPT-4 or 5 in the future, and the cheaper one, including Llama, Falcon, Mistral, Llama 2, Llama Coder, and also different tools, Wolfram Alpha, Python are the popular ones. Google Search, vector database are also popular ones. And also human beings. How can we make human in the loop smoother for developers? Well, how? As I said, yeah, sure. Multi-agent conversation is a hype right now, but how to do that? So multi-agent conversation. Why conversation? Okay, here comes another quote. Why conversation? Conversation is a meeting of minds with different memories and habits. When minds meet, they don't just exchange facts, they transform them, reshape them, draw different implications from them, engage in new trends of thought. That's from a social science perspective from Zeldin. I know this sentence is so long and complex, it's irrelevant to LLM and agents. Why I'm showing it here is because during our development of AutoGen and using of the LLM tools, we found out similar patterns and behaviors, even from the AI model. They are very human-like. And that's why we are inspired to use conversation as a main key idea or motivation for the multi-agent collaboration and framework. Let's do it a little bit deeper from engineering perspective. Why conversation? As we know, the GPT stands for generated pre-trained network or transformer. It's an auto-regressive model. It's no different from RNN or LSTMs, right? And until last year, when RLHF, reinforcement learning with human feedback, were published by OpenAI, we can incorporate instruction fine-tuning to make it more human-like and answer human questions. And the one implication from the RLHF is multi-turn to integrate feedback. So not only feedback from human beings or instruction, but also feedbacks from other AI models or external tools. For instance, the first figure here you see is an interaction multi-turn between two different agents. One agent has a Python as a tool, and another agent is connected to the large language model to give some feedbacks. Also, because of the same design, human can also participate in the conversation. And the conversation is a natural way for the human user to ask for additional tasks, insights, or provide feedback. So let's come back to the Delving's quote. So conversation can help exchange, transform, reshape, draw inspirations, and draw new thoughts for facts and knowledge. We see the same behavior in large language models. And again, that's back to ChatGPT or instruction fine-tuning. The second implication is if you have used the OpenAI API call, there is a system message you can provide. And there is a messages array where you can put the history of the chat log. That's two things correspond to other things that we mentioned. One is the memory, one is the habits. The system message is similar to the habits, and the context memory is according all the messages is similar to the memory. Because of the background, even though maybe the two agents are using the same GPT as the backend, but because the provided system prompt and the messages are different, the results and behavior for them will be different. And by the way, there is another community message about how important the messages are and the prompt are. We will not go deep into there. So there are two key concepts in AutoGen. The first one is convertible and customizable agents, where the agents, which we will discuss later, can interact with each other. The second idea is conversational programming. Well, it's so similar to the first one, but why do I draw a second implication here or key points here? We'll dive into that. The first key insights, convertible and customizable agents. There are three components within an agent. One is a language model. We draw OpenAI over here, but it can also be Llama or Falcon or anything else. And then human beings. If we want to involve human into the loop, human is a AGI, right? And the last one, tool, either Python or Google or anything. We unify the different agents together by using three member function calls: send a message, receive message, or generate reply, which involves a little bit more sophisticated logic, for instance, tool using or involving the human. So we can customize the building convertible agents into different ways. The first agent we introduced, which is the inheritance from convertible agent, is assistant agent. We set the parameter for human input to never and disable the code execution and just provide a system message, hey, you are just a system. Or we can enable the human input modes to say always, then it becomes a user proxy agent. Or we can even provide an array as a parameter to the group manager. So, hey, you are just managing the group of 4 agents here. And the second idea is conversational programming, where we have a unified interface and an auto-reply mechanism for automated chat, controlled, of course, by natural language, provided by the power of large language models. So to enable the conversational programming is quite easy. You just first need to define agents, and then you just do the conversation. Sometimes you will need more sophisticated tool rather than Python, for instance, Wolfram Alpha or Groovy or some other tools, and you will need to optionally register a customized reply function. But in 70% of scenarios, the step 2 can be skipped. And now I want to give a 20 minutes ramp up to AutoGen, and I will show you exactly how you will use AutoGen in 6 of the different applications we introduced in the paper. Well, first of all, let's install AutoGen. In terminal, just pip install PyAutoGen. By the way, it's PyAutoGen when you are type pip install, not AutoGen. AutoGen was another package. which take the name. So we are unlucky, we can just get the AutoGen name. And then you need to define a JSON file, basically provide information about your API. Which model you want to use, 3.4 or 3.5, or API key either from the OpenAI side or Azure side. And moreover, because of space consideration, I don't need more information, but you can also use smaller language models like Llama or Falcon here, either from a local host or from some other API calls. Once you have the JSON file for your API configuration, you can just export the environment variable, call it either in terminal or put in the batch RC file to configure your JSON. And boom, that's it. 5 minutes, you set up the AutoGen. Let's dive into the first application, which is math problem solving. So there are two different examples. The first one is only 2 agents, where the user proxy agent, well, just the user asks a question. And the second part is a student assistant agent. It's just you connect to the large language model and trying to answer the question. But using the conversation design, we can see human in the loop can improve accuracy. So at the first column you see here, by AutoGen implementation, the final accuracy or success ratio is more about 15% higher than GPT-4. And the writing for the code is less than 10 lines. First step, import AutoGen and the configuration, and then enable logging. Well, that's not necessary for debugging purpose. And then the design to define the 2 variables or 2 agents you have, assistant agent and user agent. For here, well, it's a little bit complex, but the most important part is LLM config. Just tell which underlying model you want to use. And from the user part, you just say human input mode to always run human to participate in the conversation. And then the user proxy can begin ask any kind of mathematical related questions. And we can even go further. Why only 2 agents? We can have 4 agents. Imagine I'm designing Piazza or Canvas or something engineering on-call system where the student asks a question. If the language model cannot answer the question, it will ask the teacher, a real human expert and human teacher. For here, we have 2 additional agents compared to the previous one. One is an expert assistant, and another one is an expert user proxy. We just need to define a helper function, which is ask expert, related to the link you saw in the previous page. And for here, the same, we define 2 agents, basically the same thing, assistant agent and user proxy agent. And the complex part is the last 3 lines, where we just define the data flow or message flow between the experts and the expert systems. And at last, the configuration for the student will change. I know this page is a little bit daunting, about 20 lines. Ooh, what's going on here? But actually just one variable going on here, which is the functions and link to the ask expert. We just tell you can use the API call or GPT API helper to link the ask expert function, which you just wrote, into the student assistant, and that's it. Everything else is just configuration and provide some background information about what ask expert stands for. So that's our first application. The second one is about RAG, retrieval augmented conversation. So which is also similar to the talk earlier by True Era. So for here, we are just streamline the RAG into 2 assistants or 2 agents. One is a retrieval augmented user proxy. The user can ask questions about their database, either a vector database or just some text files or PDF files or website or anything. And the assistant here will try to answer the question by using the content provided by the user proxy. So the user proxy, as you can see here, there is a vector database format, basically to automatically convert everything, either a text file or PDF file or code, into the vector database, and then retrieve the relevant information as context, send the context and also the user question to the retrieval assistant, and it will check back and forth. That's why we call it interactive retrieval. But the interactive are interaction between the two agents, not the user. So the user is optional. It can either intervene in the middle or just do nothing and wait for the feedback. By using the multi-agent design on the right-hand side, you can see the accuracy improves a lot. Sometimes the vector database or the nearest neighbor doesn't provide correct context, and hence the GPT or language model will not be able to provide answer. But because we can say update context in the multi-agent design, it can ask the user proxy to update the context and give more relevant information. And we have an evaluation here. So the F1 score almost doubled with the multi-agent design, and the recall increased also about 10%. Also, 10 lines of code, the rack. You just first need to improve the two agents, and then define the objects for the two agents. One is the assistant, one is the user, which is the second one, and then you can start chatting. I know the difficult part or downstream part is a retrieval config, but actually it's quite easy. You just need to tell them what model you want to use, GPT 3.5 Turbo or anything Llama, and then the document paths. Either it's a folder name or a file name, and it will automatically convert the information into a vector database. That's it, 20 lines of code. The third application is decision making in the text environment. We also compare two agent design versus three agent design. The first diagram you see here is a textbook diagram, which you can see in the RL textbook. Just the agent interact with the environment. The second one, we introduce one more agent, which is an executor. So, and the grounding agent. So they will interact with each other and provide slightly more reliable results. And we also show, which is the first column with three agents, our accuracy improves around 15% in planning and decision making. I have to say the actual coding for this environment is a little bit complex, so we can import the ALF agent and grounding agent from the source file and define the two or three agents, connect them, and that's it. Even though the backend is a little complex, but it's mostly because of the ALF word is complex. And the fourth application is multi-agent coding. I have to say, this one is the most complex one, and I'm responsible for it. Because when designing this framework, I initially with only two agents. But when I advertise or market my design to the product team, they will say, I don't trust the safety or the correctness of your agent or LLM. It hallucinates a lot. I hate it. Well, and then I define the safeguard here. By the way, it's in production right now. So I designed the framework for the multi-agent design data flow for a supply chain management product. It's now using Azure within 220 data centers across the globe. And the user flow is the user first asks a question, and then the commander asks the writer to write code to answer the user's question. And then once the commander receives the code, you will consult somebody to check the safety or correctness of the code. It can either be another LLM or a static code analysis or rule-based rules to return safety or not. Once it's safety enough, it will run the code and get the output log. The output log, as you know, in the production, are mostly meaningless or, well, maybe not meaningless, that's not the right word, but it's pretty long. The relevant information is probably hidden in some of the line, in the long couple hundred lines of lines of code. So we want to extract the information, useful, valuable information from the log. So we ask the writer again to just interpret the log for me to answer the question. And then it will translate the answer from the log and send back to the user. So that's the data flow. As I said, as you saw here, there are like 8 edges for the data flow. And that's a simple case. If some bugs happen while executing the code, the commander will go back and ask the writer, hey, your code doesn't run, just correct that for me. So it will be more complex. And here is the diagram we showcase how accurate the safeguard is. And we can see by using the multi-agent design, even with GPT-4, we can still improve the accuracy by F1 score by around 10%. And here is the code. I won't go over the code here because you can see there are 8 data flows. So I put a link here. You can just find the link and my paper to read about more details. The number 5, dynamic group chat. That's a killer application for right now for in collaborating several different agents. For here, our example is very simple with 3 agents, 4 agents. But in reality, it can be more than 10 different agents. I have 1 agent for engineer, 1 agent for PM, 1 agent for designer, another agent for some other managers or database. So all the different agents can collaborate together here by using just 1 manager. So basically, we design a manager agent and tell him or her what are the choosing agents he has. And he will ask each of the child to answer the question and to finish the data flow. And for here, so we, as I said earlier, is a simple case. Only 3 agents use a proxy coder and a PM. And then we have a manager to group them together. And then you can start to answer questions and to coordinate with database or some other tools. Okay, the last one is conversational chats. Well, this one is a little bit toy, but it's very fun. So there are 3 agents here, 2 for the players and 1 for the chessboard. And the player will make a move and will make some joke of the other player. And the chessboard will validate the move is valid and do some other rule-based check by using its tools. And here are some examples for chat during the play. I'm not a big fan of the chat because I don't know how to play. So you can judge by yourself. But what I know is how to write the code. So I will show you. You customize 2 agents here. 1 is the board agent and 1 is the chess player agent. And then you define the 3 agents together, and then you can initiate the chat by just 1 simple message, your turn. And then they will play against each other as you see in this page. And that's all for the 6 applications. Most of the application has a number of code in less than 20 lines of code, besides the multi-agent coding one. And there are more applications you can find online, including autonomous task, problem solving, and large multimodal models. So we include Lava and some other agents right now. And you can also find a lot of tutorials online from YouTube, either by DevDem or 01 Coder. And I have to thank the open source community because we got a lot of useful feedbacks and evaluations, and I will thank more than 100 people participated in the AutoGen library. And in the future, we'll incorporate more multimodality support. We will create a playground which you can use a multi-agent without writing a single line of code. And we will enable monitoring profiling mainly for production use. And we will try to manage the memory and the context flow a little bit better with automation and optimization. And that's all for me for today. Thank you very much. I will try to play this video if the internet is good. Okay, maybe not. Never mind. Yeah, I can take 1 or 2 questions. Yeah, sure.
Yeah, thank you. Really like the pitch. The agent-based, Gen AI application have been talked about a lot these days, and it's really happy to see all these great use cases. I have 2 questions. One is the first use case. You basically have an engine, if my understanding is correct, have an agent of Python, and have another GPT based agent, right? And you said my understanding is the Python agent basically just interpreted all these comments and forward dispatch it to the GPT and get a response. But in your evaluation settings, dramatically improve the either the accuracy or efficiency or whatever.
I just, have a hard time to really understand why, it will perform better, and I just simply send all these requests to ChatGPT.
Yeah. So one example is a safeguard because, well, I'm using the example because I wrote it. I know better. So one way is, why do I need multi agents? I can just have one agent. You write the code for me. Okay, now check the safety of the code. Do you think that will be a valid?
Check this.
Well
You
designed.
mean even for your first case? I didn't see there's any like safety checker over there. You see.
Oh,
like,
yeah.
right?
So,
Yeah.
so the math check, right?
Yeah, that's right.
Right. Yeah, I'm not quite familiar with that evaluation because I didn't write the code. But one thing, one thing I can infer is the user proxy agent can do some feedbacks, very basic feedbacks for the assistant agent. So it's not a single round. Hey, here's my question. Can you provide me the answer? But there are several different loops, which is dynamically designed by the user proxy.
Okay, really quick, second, your second use case, I remember you have an expert agent and you have a.
Oh,
assistant,
yeah,
right?
That one is.
And then for the assistant, in your code, I believe you used it before 06/23, like June 23rd. I think that's probably the most powerful model you can find, right? For 24, but that's only for assistants. How can you, what model you use for an expert? Because you already use a very, powerful.
Oh, yeah, yes, great question. So the difference is not on the large language model side, because LLM is not everything, even though it's not the AGI yet. Even if it's an AGI, it has its own limitation. What's different in the expert part is the human expert, because it receives feedback from the human expert's knowledge or the interaction or memory. For the expert assistant is slightly different. Even though the underlying model is the same thing, it's the same GPT-4 or same Llama, it's only inference, it's not training any new expert model. I hope that answers the question.
Thank you so much. That was an awesome presentation. And now we are going to our final presentation. Cam Young with Arise AI. Thank you.
All right. Cool. Sounds like everyone's a little experts on things we're going to cover today, RAG, agents, and you're going to get things into production. That's really where Arise comes in, is enabling, once you're getting ready for production and actually productionizing these use cases, what do I do? How do I actually ensure that these use cases are improving and not being stale and responding to incidents or issues very, very quickly? Quick intro on my end, senior solution architect at Arise. So what I do is I work with a lot of our great customers that you see on the screen. So every great startup needs a little NASCAR slide. A lot of these folks actually came to us with traditional ML applications already in place. So think about like a ranking for an e-commerce use case or a regression or a classifier. And then as they come to us, they're developing or actually have already rolled out some LLM use cases, which you might have already interacted with yourselves without knowing. Since LLMs are just really got a really quick groundswell, and some folks are still developing, some folks are still ready to go into production, or again, you're already in production. We invested across the entire life cycle of LLM applications. And so on the left side of the screen, or your left, is an icon, a little bird, Phoenix. That's something that we ported out of our actual platform. So we took key components of our platform so that you can actually use within a notebook. It's open source, just pip install Phoenix, a few other libraries depending on what you want to do. But essentially, when you're kind of thinking about developing these use cases, we're investing in tooling to make you successful so you can get into production, of course. And so when you're kind of thinking about things, you might want to think of things very macro, like, hey, are these chains actually breaking? Are there inherently latent periods of particular questions, queries, embeddings that are causing interruptions within my actual overall chains with my agents? When we're thinking about how do I evaluate my LLM production or performance, you could use LLM eval libraries. We have our own. Sounds like there's others out there, and that's great. All those are great data points for you to start using as one, benchmarking in development, and then start using to inform and actually use it as a benchmark or a baseline when you get into production. Now, why is Phoenix so great in development? You don't have to think about pipelines. You don't have to think about data leakage. You don't need to think about how's my data looking over time. But as you're getting ready for production, you might start thinking about other things. Other things like, is this the right prompt, or these are the 2 prompts that I want to start using when we release this LLM application? How are we actually just overall performing? And then last thing, you're kind of live now in production. You're going to start thinking about, hey, how much is this costing me? There's going to be non-technical stakeholders, product managers, just business key stakeholders that are investing in your kind of development. And you need to make sure that you can report on, hey, we're efficiently using token and we're driving down token usage. We're driving down costs. We're being conscious within our budget. You also need to think about proactive monitoring as well. And thinking about proactive monitoring, that's kind of the kind of entry point to observability. You need proactive hooks to actually alert you to know what's going on, where there's an issue. When you use LLM evals or any other kind of metric, you need to look at, is that going below a particular threshold or above a particular threshold that I'm not comfortable with? When observability comes in is, hey, that alert got fired off. I'm now on the platform. Help me understand what's going on within my data. What is actually driving change? Why is my metric going off? And how can I actually fix that? And once you start thinking about that and working through the opinionated workflows, you want to take that data back and start iterating on it. And so what you want to do is start thinking about things like fine-tuning your data, taking that and going to a labeling team, thinking about how do we actually enrich our vector database. Maybe we don't have coverage within there. There's novel topics that we didn't really think about and we didn't build into our documentation. Other things you might want to think about is overall evaluations. I'm going to break that out a little bit more in another slide, but another thing that might be a little novel to folks, so I have a slide on that as well, as spans and traces. So we're kind of taking and borrowing a concept that Datadog, APM, and DevOps in general have kind of pioneered, where you need to break out these very complex microtransactions, very similar when you're kind of working with agents. You can't just look at the original query and the ultimate response. You need to break out each of those steps and understand where those kind of issues with retrieval, are there issues with how we're embedding or chunking or chunking strategy as well. That's going to help you a lot there. The last thing is understanding, how do I actually improve and iterate within this platform? I identify the problem, I can start experimenting and going with a little hunch and seeing what actually reacts. As LLMs can be a little bit of a black box or a little bit more, let's see what happens. You just start playing around with your own data within the platform. Breaking out, one of the most common questions as I work with customers is, hey, like, what do I do with user feedback, or how do I think about performance? I think you can use a combination of these. These are all, again, just signals to help you understand where you should start zooming in on, but it's not going to be the end all be all. It's just a number, it's just a data point, it's just a value in a row in a column of data. But fundamentally, you can use things like explicit thumbs up, thumbs down. Of course, you're going to get a lot of bias between that because not everyone's going to give you thumbs up, not everyone's going to give you some sort of feedback. And so a lot of those are going to be blank. You can use things like implicit signals. So if you think about it in an e-commerce scenario or even a service chatbot, you have a chatbot, someone interfaces with it. Typically, when you deploy a chatbot for service, you want it to deflect some sort of low-level tickets so that you don't have to deal with that as an agent. You can drive average handle time down. So what you can do is, did it get escalated to an agent? That could be an implicit signal for you to capture, and again, use as a signal to help you understand, hey, we're getting a lot more escalations. This is something I should actually look into and actually understand what's going on. What changed within the interactions of the users then? You can also use LLM evals. I'm not going to go into that as much, but overall, just worth noting, we don't really care who you use. You can use our library, we do benchmark them, but at the end of the day, again, it's a data point you can consume. The important part is understanding monitoring and the troubleshooting workflows to actually expand upon just a kind of a roll-up number. The last thing is, embeddings are everywhere within LLMs, whether it's kind of abstracted out when you kind of work with ChatGPT or Bedrock or anything. Fundamentally, what it's actually looking at and utilizing are those embeddings. And so a platform really needs to enable the utilization of those raw vector arrays in order for you to actually have a very good signal. So think about very large distance metrics like cleaning distance or cosine similarity. That could be another signal for you to use as, hey, in primary data or what we're doing in production, compare that to my baseline, which could be a human labeled data set. It could be last month's worth of data. Understanding change between those using some sort of high dimensionality, and then actually being able to explore those points within an intelligent interface is another key to observability. And of course, you can use task-based metrics, but we don't see very many folks using those as much. Last slide before, it seemed like everyone was just going on slides, so I'm gonna treat you to a little demo and seeing this in action after this slide. But overall, thinking about spans and traces, there's a lot of different types, but you can kind of think about using the embeddings, using the retriever, the agent, everything. So these can be very complex interactions in within kind of one single kind of prompt and response. You need some sort of tool to kind of break all those out there. So I'm going to pop over to another tab and show you a little bit of what we have. So I'm going to bounce back and forth here, but overall, landing in our platform, this is when you're in production. You're going to be collecting basically prompt and response logs. Down below here, what you see is that we're consuming two things. One is the embedding, so the prompt and response. We're looking at the raw text. You'll see that in the platform in just a second, as well as tags are basically where you can send any kind of metadata. So that can be things that you generated through LLM evaluations, which you actually see through OpenAI Precision 2, OpenAI Relevance there. So we're consuming these data points into the platform so that you can actually use those data points to kind of build out metrics and get monitors. A little background on this model, it's actually our own data. We basically took our own knowledge base, chunked it up, put in a vector database, and then myself and a few others just threw some common questions that customers asked us to generate demo data. So we'll kind of move into using this OpenAI precision score. And what you can do very easily within our platform, because the eval libraries can catch anything. It could go from hallucinations, it could go from retrieval scores, it could go for groundedness, it could go for profanity or jailbreaking scores, etc. So what we're doing is we're just allowing you to reference that column down below there, OpenAI Precision 2, give me an average, just tell me that metric. And what you can do more powerfully is start using that to build out things like a monitor. And so I kind of already pre-built one out, just as it's a little quick of a demo here. But you can think about like eval alerts here. So when you have that number, that's great. You don't want to be now stuck back in a spreadsheet kind of looking at, hey, filter me by where it's less than 0.6. Just give me that kind of alert so that I don't have to create these kind of cron jobs or some sort of hack to start evaluating this data in perpetuity. That's part of our platform. We're going to give you alerts. We can also kick off kind of automated workflows to kind of revert back to previous kind of prompt versions if something goes egregiously wrong. But what you can also do is go into troubleshoot mode. And so we're going to go from like very, if you will, familiar. So if you have just an LLM out in production, this might feel a little familiar with the table view down below. And we'll kind of expand on that and end on thinking about embeddings and how do we project those. But overall, what you see here is I'm just giving you the average. You know, we're at 65% user feedback score. It's just passing in most schools. And down below, we have a tabular view. Again, this is what a lot of our customers are doing right now before they use Rise. They get a kind of a table view, and then they can, you know, do some conditional filtering, like, hey, give me let me look at all my kind of prompt and responses for production only. Now it's just a point and click. Again, I can just quickly filter this data. I can now actually compare that against, maybe we're looking at a prompt that I'm testing out, and I have that flagged as a test prompt. So what I can do is look at that and compare the performance of those two. And so what I can do is I can start looking at, hey, like we're actually outperforming here. We're at 15% delta between those two kind of prompts. So maybe this is actually a good place for me to start understanding, hey, maybe maybe this is a time for us to release it, promote this new test prompt into production. What I can start doing is now, instead of looking at this table and start, you know, spot checking, going like, okay, does this look like a good prompt and response here? What I can do is actually start utilizing and relying on those embeddings. And so whether it's using a baseline or just comparing two different data sets, what we're doing is we're using a technique called VMAP. And taking all those, it could be 50,000 dimensions of those embeddings. We're taking that into a 3D space to make it friendly for us to explore. And what the kind of rule of thumb here is, things that are going to be similar are going to be clustering together or grouped together within this space. Things that are dissimilar are going to expand apart, they're going to drift away. And so what you want to do is kind of identify those clusters. So you see them on the left side, our clustering algorithm is pulling and identifying relevant clusters for me to look at. And remember, my kind of metric here, or the custom metric, that column there, that's user feedback. So negative is bad. And so what I can do is I can quickly go, okay, in my production prompt, we had negative 0.38. And then we're actually outperforming at a 0.8. So that's a huge difference between the two different prompt performances. What I can do is I can select those clusters. And then I can start either very quickly, see that download cluster. I can go, hey, let me send that to my labeling team so we can investigate this further and understand what's going on. You see within here that we have all the points kind of displayed here. So we're going from big global signal of, hey, user feedback's going up or down, to identifying meaningful data so that I don't have to boil the ocean. I don't have to hope I find something through randomly sampling my data points. But what I can also do is get very local as well. And so as I kind of start understanding what's going on in this cluster, I can look at a single prompted response. I have all the metadata available. A lot of this is optional, but it'll lock one thing that I'll show you at the end of this demo. But overall, you can see, here's my prompt, here's my response, here's my test, the template name. What I can do is I can start kind of going on intuition and experimenting there. And so what you can see here is I can actually rerun this entire prompt by changing any of the levers. I can change the template if I want to say, hey, what if we change the template? Would this actually give me a better response? What if we changed the bet and improved what the context of that data was retrieved down below, because those are imputed values? I can do that. Or perhaps maybe where I'm getting asked, hey, I see that you're using GPT 3.5 Turbo. We're kind of thinking about using GPT-4. Are we going to see a big delta and uptick in performance? You can rerun this with all those various parameters within the platform and start actually being a lot more comfortable and confident that, hey, with these changes, I saw a good uptick here. Let me start actioning on that internally. The last thing I'll kind of tie off here is I kind of mentioned reporting back up to non-technical stakeholders. You can also build out very customized kind of visualizations, whether it's user feedback by template, model performance compared, or just give me a big number. Give me a roll-up number of like how much is this costing per call, how many tokens are we using, what's the average use of tokens, etc. So overall, what we want to do is make sure that as you put in all this work in development and getting ready for production, you're just as successful from day 1 to day 300 in production for LLMs. So that's what feel free to use Phoenix. It's just phoenix.docsphoenix.com, and I'll be here for questions.
Next, we'll have a hardware demonstration that's set up. So we actually have time for a few questions if you want to do that.
Sure.
Like 1 or 2.
Thanks for the quick question. So, how is this significantly different from any of the other dashboarding solutions that are currently out there? Or this is more of a flavoring of LLMs that is one on top of those things. That's one part. And the second part is the open source app. Is that more of an endpoint, something like an ML flow that you plug in to pass things over to the dashboard? Is that how that's set up?
So to answer your first question, I would say ML is very different than what most folks want to visualize within, like, say, Tableau or Power BI. So you need something that's basically a schema aware of the typical structure of data of ML and now Gen AI on that. So at the most like basic level, you're going to think, dashboarding like that, plot a number over time, show a distributional graph. That's really not the most complex thing. The more complex thing are the kind of troubleshooting workflows that a lot of folks call dashboarding within the platform. So when you kind of look at things like this becomes very difficult to do at scale, where you're doing like a slice level view and like calculating that and understanding what a feature is, what a prediction is, and understanding really a prediction is that core crux of ML. The second question is, a lot of these things, so like the embeddings view, dashboard's a little less like the true dashboard that I ended on. That's not really included in Phoenix. So Phoenix is basically notebook, install it, you send the data, but it's still locally running in your notebook. And then it gives you these kind of visualization tools that a lot are in our platform. So kind of get familiar, the kind of aim is you get familiar with these flows. And so as you develop, you can use those same flows to troubleshoot as you release it into production.
If it's okay, we'll have more time for like all of the open discussions and questions. We can like break off into groups later too. But yeah.
Okay, so, as I said before, my name is Richard Sprague, and, I got a startup called AutoGen, and we make this little camera that I have right here. There we go. So, it's really hard to hear. So,
I think his name is Richard.
Oh.
We have another one. Well, here. Yeah, Richard is. His name is Richard.
Oh yeah.
So what we do is we take
Yeah, we have another one called Skyline.
Okay.
and then you send it to the cloud, where we got this AI algorithm that's been trained on over 20 million labeled images that describe people's eyes in according to various different health conditions. And so then we have a classifier. This is a multi-level deep learning model where we classify your image against all the ones that you see. And after we've done that, then we're able to give you a risk score. And the way it works, I just, all I have to do is look at, I've got a QR code in front, and I scan the QR code with my